Okay, I think it's time to start. So, hello everyone, my name is Dimitrios Kalogeropoulos, and today I'm going to present for you the driver modernization for OpenVMS x86. And before I start with the agenda, I would like to introduce myself. I have 8 years of experience in embedded and networking systems, and currently I work in TerraCloud as a software engineer team lead, and I am the member of the Greek team. We are working on OpenVMS based on OS development, and our team consists of 10 talented software engineers and 1+1, I would say, QA engineers, because one new member will join next week. And I started my OpenVMS experience with the VM Tools project that Nicolas Tavoularis had the presentation earlier today, and now I am dedicated to the drivers, and specifically I work on the iSCSI support for x86. So today I would like to speak about the driver modernization, and I will start my presentation with why it's important, this procedure, the challenges that we face, what we want to achieve through modernization. Then I will continue with the strategy that we follow for OpenVMS x86 modernization. I will give you a brief update of the drivers that are in the latest release of OpenVMS and are part of this modernization. And I will finalize my presentation with the benefits of this procedure. So, as you may know that now we are fully supported on virtualization platforms. Either we run on VMware, ESXi, or on KVM for Red Hat Enterprise Linux and Oracle Linux. Of course, drivers is the key link between the guest, which is OpenVMS in our case, and we have two different now cases. It can be either the hypervisors through emulated and paravirtual devices, or the hardware directly. This can be achieved through PCI pass-through devices. What we want to achieve with modernization, we want to ensure that we are reliable and we have high-performance VM deployments, not only for today, but also for the tomorrow's infrastructure. So what are the challenges now that we face? Of course, the traditional OpenVMS environments run on bare metal hardware. So there's a difference here that we are on x86 because we have many drivers that were built for previous architectures like VAX, Titanium, or Alpha. And now on x86, we have a diverse ecosystem of multiple vendors that we want to support or we could support in the future. So each vendor can provide specific device driver operations and some firmware behaviors that we need to adjust. That's why there is a need to develop some new drivers for 3 different kinds of devices. First, emulated devices. This means that are some devices that are emulated by the hypervisor in order to look like a real device. Secondly, some paravirtual devices. These are devices that are implemented by sharing some memory with between the hypervisor and the guest. And lastly, we want drivers for PCI pass-through devices, which in this case we want to support some physical controllers that are exclusively assigned by the hypervisor to the guest VM, and the OpenVMS can communicate directly with these devices. Of course, we know that we run on VM, so there may be some concerns about an overhead regarding the performance. We may have some performance gaps, and especially when we compare it with bare metal architectures. This could be for storage I/O and network I/O operations, but as Claire earlier today presented, we may do not have so much gap between the x86 environments and the previous architectures. So what we want to achieve with this modernization procedure? First of all, we want to be maintainable. we want to use the C language, which is more maintainable and more portable language compared to the VAX macro, where many drivers are written. VAX macro is basically used for backward compatibility, so we don't want to add new features in VAX macro. We want to have a C code base of drivers, which is easier for us to fix some bugs, and of course, to train the new generation of OpenVMS developers. Next, we want to be reliable. It's important for us to have a stable OpenVMS operation, like all the previous architectures run. The stability was, as Camille and all the other colleagues mentioned in this bootcamp, is important. It happened for other years. We want also to be stable in x86 environments, which also we don't want to be affected by integrating multiple support platforms. So we want to combine these two. Next, utilization of the paravirtual devices is important because we want to bypass emulation and communicate directly with the device in order to have some specific device operations. And of course, x86 CPUs provide some powerful hardware features that we may want to utilize in the future. For example, AVX support, the vectoring structure could be used for some data, accelerating the I/O data movement between some I/O operations. And of course, we want to future-proof the OpenVMS environments. We want to keep our architecture modular in order to have new features that we can plug in our drivers. And of course, we want to easily adopt new technologies for VMware and KVM platforms. What is the strategy that we try to follow for the driver modernization? First of all, VSI maintains a policy of ensuring forward sourcing compatibility. So we want well-behaved applications that operated in previous architectures like Alpha or Integrity. We want to successfully run these applications in x86, OpenVMS x86. This can be achieved by conditionalizing our code base based on the architecture in our building procedure. And in some times, we may need to restructure some existing drivers. But of course, the importance here is not to affect the functionality of these drivers. And of course, since we are no longer running bare metal, some drivers need to be phased out, have no longer existence, in our case for x86. But we run on VMs. This means that we can support new drivers. So it's important for us to develop and optimize some paravirtual drivers for KVM and VMware platforms. And all the three strategies, let's say, that I mentioned before, requires for us some improvements in our tooling. This could be either writing some drivers from VAX macro code to C, or upgrading our building procedures in order to use modern compilers and, of course, compilers optimizations. So I would like to give you an update of the current drivers in OpenVMS x86 that have been established from the 9.2-3 version and later. I have split some drivers into 4 categories. So the first one is the block drivers, some configuration enhancement for SATA devices have been established with the update toolkit in version 9.3. And although we supported the fiber channel cards for 16 HP and 16 gigabit HP logic cards in the version 9.2-3, with the update toolkit, we can now support also the 32 gigabit fiber channel cards. Paul Jacobi gave a presentation yesterday about this feature. And of course, as we will see later, for the PCI pass-through support in both KVM and VMware. Then a work that is under progress from the Greek team is the rewriting the decade driver SCSI class driver for VAX MACRO to C. This is the first part of this procedure, and later, of course, we can make some performance improvements in this in order, let's hope that this will be included in the 9.2-4 version. And of course, many references to this project, the SCSI support, and will be a major feature in the next version of OpenVMS release. And this is also part of the Greek team project. Another driver modernization could be the existence of the guest console driver, which is part of the character drivers, since we give an alternative to the user in order to not rely only on the serial port, but also use the terminal from the booting process until the login.
Very much.
Then we can have some network drivers that existed from the version 9.2-3. There are these paravirtualized drivers for KVM and VMware, VirtIONet and equivalent VMXNet support, and also the clustering driver that the P driver can now use some 64-bit counters and will be available in the next release of OpenVMS. Similar to decay drivers, some TCP/IP and LAN drivers are also rewritten from VAX MACRO to C, and some optimization will be also applied in this case as well. And finally, of course, we run on VMs and we support two different hypervisors, VMware and KVM. So first of all, VirtIO SCSI, the paravirtual SCSI device port driver, and which in the next release will also support the fastpath. We have also for KVM the RNG driver for random number generator in KVM will be also included in the next release. The paravirtual SCSI driver, which is the equivalent of VirtIO SCSI, is under progress again from the Greek team and maybe included in the next major release. And finally, with the update toolkit, as I mentioned before, we don't only support the VMware ESXi for PCI password device, but we also support KVM for the same HVAs. So what are the benefits of the driver modernization? From the one side, the VSI company can benefit by having a code base that is easier to maintain, since we want to have modular drivers that are written in C. And this provides a clean foundation for us in order to make the debugging cleaner and also testing. This means also that we can faster deliver every new feature that we may need in the future. And also, we want to be market competitive by keeping the OpenVMS modernized with the industry virtualization standards. And of course, OpenVMS, we want to remain a stable long-term platform. From the customer side, they can also benefit by having a broader wide hardware support, since we can leverage new technologies for storage, networking, and generally it is easier for us to adapt in more vendors. And of course, performance always matters. So as also Claire mentioned in his presentation, paravirtual drivers, for example, the VirtIO SCSI, can provide near native I/O speeds. This means for customers that they can run their applications with fewer resources, so lower CPU head and higher throughput. And I would like to conclude my presentation that driver modernization can be one of the keys that can link the past with the future according to the vision of our CIO. So thank you for your attention. I'm happy to answer any questions that you may have. Yes.
One observation there. One thing that would be really useful is a USB port driver, powered virtualized. There are lots of peripheral devices that now use USB as a connection, particularly the high-speed USB. And writing a user-written specific device driver is not that bad, but the powered virtualization interface to the host VM to get to the physical USB is a different discussion.
Yes.
We really would be helpful in expanding potential use if that was on the list. Not tomorrow, not maybe 6 months, but on the time pipeline, a USB port driver, just like a SCSI port driver.
But I think generally we're open to any suggestions that can be into priority, and USB driver can be one of
A
these.
USB port, a USB port driver that a device driver could use as a filter to get to the USB.
Mhm.
Not a callable thing, but something that accepts QIOs.
Correct.
And
Yeah,
talk out the USB.
I agree, and this is why we want to keep this modular. We have this class driver, and every port driver may be needs to be adapted or either implemented from the beginning. If there aren't any other questions, thank you for attending.